Hello, welcome to our next video about statistics. Today we're going to talk about probability distributions. Before we talk about a probability distribution, we have to talk about discrete and continuous variables. A discrete random variable can take on a finite number of possible values, so like 1, 2, 3, 4, 5. In this case, the number of accidents per year. So you're going to have a specific number that you stop at the end of the year. A continuous random variable can take on an infinite number of possibilities. So all of the numbers between 0 and 10. Well, technically, we have all the whole numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but we also have, fractions and decimals in between those numbers. So there's technically an infinite number of numbers there. In a real world example, you have the number of miles driven. And you can drive 3 miles, or you can drive 3.1 miles, or 3.2 miles, or 3.3 miles. So that number could be anything in between your two numbers. It's not like you have a finite fixed whole number type situation. So let's look at a couple examples of discrete and continuous random variables. We have where the discrete random variable x, which is just a very popular thing to call a random variable, represents the number of times a phone rings before it is being answered. That would represent a discrete random variable because the phone will ring 3 or 4 or 5 times. It could technically keep going at integer values forever, but eventually the phone will stop. So this would be a discrete. This next one says classify as discrete or continuous when x represents the amount of time between when the phone first rings and when it is answered, and explain your reasoning. So that can be a continuous because again, there's not a fixed stopping value. You can always keep thinking of it in terms of like sub-intervals of the larger set. So this would be a continuous random variable. So now let's talk about a probability distribution. First, we're going to talk about sample space. And sample space is just all your number of outcomes. So let's say that I want to flip 2 coins. I have a coin in each hand and I throw them up in the air and drop them. What are the possible outcomes? Well, I could have 2 heads. I could have 2 tails. And my first coin could be a tail and my second coin could be a head, or my first coin could be a head and my second coin could be a tail. Depending on the description of your situation, tail, head, and head, tail could be 2 different things, but since we're dealing with 2 totally different coins, I'm going to count them as 2 different things. So then what's the probability of getting 0 heads, 1 head, or 2 heads? So when we're talking about this, your variable x is the probability of getting a head. So we can make a nice little table here. We have number of heads. And your options are, again, 0, 1, and 2. Again, this is discrete because our options are 0, 1, and 2. So the probability of getting 0 heads would mean that I actually got 2 tails. So that would be 1 out of 1, 2, 3, 4 total options. So 1 out of 4. And then the probability of getting 1 head, well, both of these have 1 head in them. So that would be 2 out of 4, which is 1/2. And then the probability of getting 2 heads would just be 1 out of the total 4 options. Now, this is known as a probability distribution table. So you have all your possible outcomes over here, And then you have your possible probabilities over here on the right. And you could do this table horizontally if you wanted. It just depends on your personal preference. If you have a proper probability distribution, then you have these conditions. The probability of each value of x will be between 0 and 1. And sometimes you'll see probability described as P of x. So P standing for probability and x standing for your variable. And then the sum of all of the probabilities, and this is a great way to check yourself, of x must be equal to 1. This symbol here means sum of P of x equals 1. And if you notice, 1/4 plus 2/4 plus 1/4 equals 4/4, which is 1. So it's kind of a great way to check yourself and make sure that you've done it correctly. So this is your probability distribution table. Here's another example. Moviegoers were asked to rate a movie. The possible rankings were 1 for poor, 2 for average, 3 for good. Use the frequency distribution shown to construct a graph and graph a probability distribution for the random variable. We're not really worried about a graph right now. So we're just going to construct a table. So this time, just to be different, I'll do a horizontal table. So here I have my rating, which is my x. And my rating could be a rating of 1, a rating of 2, or a rating of 3. And then my frequency. So this is my frequency. This is not my probability. So be careful here. This is just telling you how many individual people voted those things. So first, let's calculate a total. We got to figure out what 12 plus 14 plus 37 is. Because to calculate probability, you need to know how many total things you have. So my total is 63. So my probability, or my P of x, this is out of 63. So this is 12 out of 63, 14 out of 63, and 37 out of 63. And you can, if you want, express these probabilities as percentages. Sometimes when they're weird ones like that, a lot of times we prefer to think of them that way. But you do get into a little bit of trouble because you're going to end up with repeating decimals. So when you check yourself, by making sure you add up to 1, you have to realize that if you round, you probably won't actually add up to 1. You might be a little bit less or a little bit over, depending on how well you round. Because I know 12 plus 14 plus 37, that's 63. So it would be 63 over 63, which would be 1. But 0.19 plus 0.22 plus 0.59, that actually does end up giving me 1. So I guess I'm pretty good at rounding. So we find the probability distribution, so that way we can find our next thing, which is the expected value. And sometimes we call the expected value E of x. Oops. Again, the expected value of our variable x, of our probability variable. The expected value is what you're expecting to get out of the table. So like if you were to grab a random person, what would that person say? It's the same thing as finding the mean of the probability distribution table. Either way you do it, or either way you think of it, all you have to do is multiply basically down these columns and then find the sum. So you had a 1 rating at 12 over 63. You had a 2 rating and that's 14 over 63, and then you had a 3 rating at 37 over 63. You're going to get a gross decimal, which is fine, but your expected value for this would be 2.396, so I'll just say 2.4 after you pop that in your calculator. So this is your expected value, basically your average rating, if you want to think of it that way, but it's also considered the value that you expect to get out of the table. Let's do another expected value problem. The probability distribution of a particular test is shown below. What would you expect a student to score on this question? So this time note you already have your P of X calculated, so you don't have to calculate it here. It's always very, very, and very, very, very important that you pay attention to what your table is giving you. If it's giving you the frequency, you have to calculate the probabilities yourself. If it tells you P of X, then you don't have to do any work except do some multiplying. So you're just going to multiply straight across all of these rows and then add them up. So 0.02, and then we have 2 times 0.16, which would be 0.32. Then we have 3 times 0.4, which is 1.2. I'm not doing a very good job of lining these up. And then we have 4 times 0.32, which is 1.28. And then 5 times 0.1, which would be 0.5. Then calculate those up. Add all those numbers up. This will give you your average or your mean of the probability distribution table. It also gives you your expected value, which again is just the number you're expecting to get out of the table. So what would you expect a student to get on this question? The sum of all these, after you multiply across the row and then add them all up, find the sum, is 3.32. So your expected value, your E of X, for this particular question would be 3.32. And that's all we have for this video today. Feel free to ask me any questions, and as always, make good choices.